Hi everyone, I'm Amrutha, Assistant Professor from Computer Science Department. Today I'm going to take a session on advanced data structures. So you will be knowing about what is a data structure is. A data structure is very important programming concept. Actually, it is not a programming language like C, C++, Java. It is a set of algorithms that we are using to program for in order to store the data in the memory. So data structure is a storage that we are using to store and organize the data. So we can, while efficiently storing the data, we can easily retrieve the data in a faster manner. So there are different types of data structures are available, such as array, linked list, queue, stack, etc. So for an example taking for a data structure that is an array is a continuous data memories. In that, the elements are stored in a continuous manner. So in other words, we can say that the elements are in a continuous manner stored. So there are other data structures like queue, stack and all. We can be discussed in the coming slides. So this one I already told that the program data structure is not a programming language like C, C++ and all. It is a set of algorithms that are used in the programming language in order to store the data in the memory. So these are the major operations which we can perform in the data structures, such as searching, sorting, insertion, updation and the deletion. So in searching means in order to find a particular element in the data structure, we perform the searching operation. The second one is sorting. In order to sort the elements either in ascending order or in a descending order, we can perform the sorting operation. The insertion, in order to insert an element, we can perform the insertion operation. We can delete an element from a data structure too, and also we can update the element. So these are the operations which we can perform in the data structures. That first one is searching, sorting, insertion, updation and deletion. So next we are going to discuss on the types of data structures. So now we understand what is a data structure is. Now let's check out what are the types of data structures. Mainly we can classify the data structure into primitive data structure and non-primitive data structure. Primitive data structure means you will be knowing that the primitive data types such as which are in pure form such as integer, float, character and all. That is primitive data structures. Non-primitive data structure means we cannot implement the non-primitive data structures without using the primitive data structures. So the non-primitive data structures can be classified as linear data structures and non-linear data structures. So we can be discussed in the upcoming slides what is linear and non-linear. In linear data structure, which again can be classified as static and dynamic. For static the array is an example for static data structure. For dynamic, linked list, stack and queue, which is an example for the dynamic data structure. The non-linear data structure, which can be example as tree and the graph. So coming to the first one, that is mainly the data structure is classified as primitive data structure and non-primitive data structures. In primitive data structures, it is the primitive data types such as which are in the pure form. That is integer, character, float, which all are in the pure forms. Such data types are known as primitive data structures. So the point is you will be knowing that we are not storing the data. Instead of that, we are storing the memory address. So we can call it as the pointers which are the reference data types, because we are not storing the data, instead of we are storing the memory address. So the next classification is non-primitive data structures. Without the non-primitive data structures, we cannot implement the non-primitive data structures. With the help of that only we can implement the non-primitive data structures, because they are in the pure form such as integer, float and all. So with the help of that only we can implement the non-primitive data structures. So the non-primitive data structures, which again can be classified as linear and non-linear. The first one is linear data structures. What is linear data structures? In linear data structures, the elements are stored in a sequential order. A particular order will be there. In a sequence manner, the elements are stored. So when the complexity of the program increases, it is not perfect to choose the linear data structure, because the complexity gets increased. So I already told the linear data structure can be classified as static data structure and the dynamic data structure. Static data structure means, in the case of static data structure, we allocate the size during the compile time. that is fixed size. We cannot increase the size during the runtime. If we want to increase the size during runtime, we cannot do that in the case of static data structures. Array is an example of that type of data structures. The second one is dynamic data structures. In the dynamic data structures, we can increase the size. That means it is flexible to increase the size according to our need during the runtime. That is the difference between the static and dynamic data structures. The linked list stack queue, which comes under these dynamic data structures. Next is about the array data structure. Array data structure, which comes under the linear data structure, and also it is a static data structure. So in array, what an array happens is the elements are stored in a continuous memory locations, and also the elements of an array are of the same data type. That is, for example, if the first element is an integer value, the second element will be also an integer value, not will be a floating value. That is, the same data type will be stored in the array, and also it has an index from 0 to n. Based on that index, the elements are stored, and also the elements are stored in a continuous memory locations. So the next comes under the linear data structure is stack data structure. The stack which works on the principle of last in, first out. That means which element comes last, that elements will be removed firstly from the stack data structure. For example, if you are inserting elements in the order 1, 2, 3, it will be placed like this. There will be one side for the insertion and deletion operation. So what happens is which element which is on the top of the stack. Here 3 is top of the stack. So the 3 will be removed first. Then 2 will be removed, and then only the 1 will be removed. That is, it works on the principle of last in, first out. Which element comes last, that element will be removed firstly from the data structure. The next is about the queue data structure. Queue, which is also a linear data structure. In queue, there will be 2 ends there. But in the case of stack, there is only one end. So deletion and insertion and deletion occurs through that end. But in the case of queue, there will be 2 ends are possible. From one end, the insertion occurs. From the other end, the deletion will be occurs. So it works on the principle of first in, first out. Whereas stack, which works on the principle of last in, first out. Whereas queue, which works on the principle of first in, first out. So if you are adding the elements in the order 3, 1, 2, it will be added like this, and the first, which element comes first, that is 3. So 3 will be removed first. Next comes the linked list data structure. The linked list data structure, which is also a linear data structure. In the case of linked list data structure, there consists of a node which consisting of 2 parts, that is a data and also the address to the next pointer. That means these nodes will be connected. In the case of linked list data structure, the difference between array and the linked list is that the array is a continuous memory locations, the data is stored. But in the case of linked list data structure, the data elements are not stored in a continuous manner. So it is connected by the links. So which node comes next, that address will be stored in the node. So this is about the linked list data structure. So next is about the non-linear data structure. Now we have already known what is linear data structures. In a linear data structure, the elements are stored in a particular order. So whereas in the non-linear data structure, there will be no such order will be there. That means no sequential order placements will be there. The elements are arranged in a random manner. Such best examples are trees and graphs. Let's check it out. That what is it? In the case of graph data structure, there will be consisting of nodes and the edges. The nodes will be connected by the edges. The nodes which can be either be called as vertices too. So this is a randomly the elements are placed. This is the difference between the linear and the non-linear data structure. In the case of tree data structure also, the elements will be placed in a hierarchical manner. That is, multiple levels will be there. The elements are arranged. So this is all about the types of data structure, and I think by this session you will understand what is a data structure is and the different types of data structure and that's all of today, and thank you.